Hey everybody, it's Mrs. C coming back to you with some more word problems. I don't know what I'm going to call this video. I already did a video on even more word problems, so this is even more, even extra more. But these are a little bit different. These, as tiny as they are, some of them are just a scone bit saucy. So I wanted to give you a couple examples, just plain word problems, because number problems, I guess I should call them. We've been doing problems that were specifically perimeter, and I like doing perimeter first because perimeter is very concrete. You can see the shape. These you don't necessarily see the number, so we have to come up with a way of making these problems as concrete as we make the rectangle problem. So let's just look at the first one, letter D. 7 times a number is the same as 12 more than 3 times the number. Find the number. What? 7 times the number. Who? What number? 7 times a number. Okay, I don't know. Here, let's start with a number. What should we call it? Let's call it N. Okay. It's telling me that 7 times that number is the same as something else. So is the same as is setting them equal to each other. So if this is my number, let's put you in a little frame number. That's you. Ta-da! And I need to set up a couple constraints on this and give myself an equation. It's telling me that 7 times that number is the same as something else. So, okay, here's 7 times the number, right? And that's supposed to be equal to 12 more than 3 times the same number. And that's the number, right? So how do I express 12 more than 3 times the number? Remember, more than, less than. The number has to be adding to or subtracting from something. That's why that 12 more than is going in the back, because it's 12 more than something. It's 12 more than what? 3 times the number. What's the number? N. What's 3 times that? 3N. There's your setup. And so it's as simple, guys, as doing that and then solving for N. Now I want to get rid of that line. I don't want to think, oh my gosh, when I do that, the other side of the problem comes up. Okay. Little movie magic there. I forgot to erase with the right color. Okay. So it's the same as just a little baby two-stepper. So I'm going to minus my 3N. Didn't come out. Minus my 3N. Isn't this getting easy, right? Got the 12 on this side. I've got the 4N on this side. Divide both sides by 4, and I am on it. I've got N is equal to 3. So now I know what N really is. N is supposed to be 3. So the number is really 3. But you're going to find that I didn't give you an answer key on this page, and kind of on purpose and kind of by accident. I cropped it off. And then before I went back to go recrop, I thought, wait a minute, you can use your process of evaluating to check step this and see if it makes sense. What do you mean by that? Well, take 3 and play this scenario out again. See if it works. So if it's true that 7 times a number is the same as 12 more than 3 times that number, let's do it. My number's 3. So what's 7 times 3? Well, 7 times 3 is 21. Then it said it's the same as if we add 12 more, it said it's the same as 12 more than 3 times the number. Well, how do I add 12 more to something if I don't have it? This is the whole point. I have to do 3 times the number first. 3 times 3 is 9. If I add 9 and 12, guess what I get? 21. It checks out, and that's your check step. So that's how I want you to check the problem, but I want to be very specific here. I do not want you plugging that 3 back in here, and there's a reason. What if you translated it wrong, but you solved it right? Then this check step is going to show you're right. What you need to do is go back to the original problem and use your mind and wrap your mind around the situation they're talking about and see if with your value that situation word for word makes sense. You purposefully remove yourself from your translating that you did or your math, because if you did it, I know I saw it, if you did it wrong, it's just going to show you're right because you translated wrong but you solved right. You better be solving right. We've practiced enough solving, right? Right? Okay, let's kick it up a notch. Let me see. Do we have any a little bit saucier? Okay, how about C? C looks fun. So we have C. One more than three times a number. Okay, again, who's my number? Let's call your number N. So one more than three times the number, one more than three times the number is the same as 5 times the number decreased by 15. Now, I don't put the 5 in the back because it says 5 times a number is being taken down or decreased by 15. 5 times a number being decreased by 15. That actually writes in the proper order. The only time your order is reversed, where the number goes in the back, is when you hear that more than something, less than something, decreased by, not decreased by, okay, I'm drawing a blank on different other words besides more than, shorter than, longer than, taller than, the fatter than, skinnier than, all of those, but usually the word than is attached to it. Okay. So now we have not necessarily a two-stepper. This is a multi-step problem just because I have some moving around. I don't have combining, but I do have to move my numbers and letters. I'm going to move my 3n to the right. I like keeping my n's positive. And then I'm going to wind up with a 1 equal to a 2n minus 15. And then I'm going to add my 15. The screen is bothering me. I know you know it. 16 is equal to 2n. Sorry, I forgot to do that. Divide by 2. You see that n is equal to 8, or so we think, right? Now we're going to find out. Is n equal to 8? Come back to this problem. Don't look at your process. Don't plug in the value of 8 here and here. We want to run through the scenario, and I'm going to just be confident here and assume I didn't screw up. I'm going to erase my process because all I have now is the word problem, and that's all I need. It says one more than 3 times a number. Okay, what is 3 times the number that I think it is? What's one more than 3 times 8? So we want to do 3 times 8, right, is 24, and one more than that is 25. Now, it said that's going to be the same as 5 times the number decreased by 15. You'll see the order changes. 5 times the number, I actually do 8 times 5 first. And 8 times 5 here, in this case, is 40, and then I decrease, and I'm going in the order that it had appeared in my process. So, 5 times the number 8 is 40, decreased by 15. Well, 40 decreased by 15, 40 decreased by 10 is 30, and 30 decreased by 5 more is 25. This is really key, guys. You're checking it in your head, almost trying to prove you're wrong, not trying to prove you're right. So when you're doing the math in your head, please make sure that 40 minus 15 is truly 25. I know you want it to be 25 because you want to be right, but really, honestly, if it's wrong, you want to realize that. And so you really have to pay attention. If the math is telling you you're wrong, you need to just see it and admit it and go back to the process that I erased and check it out, see what you did wrong. So here are the other side of crazy, right? This is the other side of crazy. This is the other side, which does to me appear harder. I don't know if it is, but it just has that look. So I'm just going to quickly and sloppily erase here. Okay. Now, I'm just going to go for, I'm trying to see, I don't see that anybody is really any harder than anybody else. They all look the same, and I like how this stupid hint, pardon me, but we don't need a hint. Who needs a hint? All right, let's do that one because it's annoying me that they didn't let us put ourselves up to the challenge of translating it on our own. So it says the sum of two numbers is 35. Oh, the sum of two numbers is 35. Okay. If you add two numbers together, especially when you get an odd answer, 35, can the numbers be the same value? Can I add two numbers that are the same numbers and get an odd number? Let's try it. 2 plus 2. No, that's 4. That's even. Okay, well, those were two even numbers. Let's try odd. 5 plus 5. That's 10. 15 plus 15. 30. 9 plus 9. 18. 6 plus 6. 12. Every time you add a number to itself, you're going to get an even outcome, right? So in order to get an odd outcome, these numbers have to be different. Now, that really doesn't matter to the problem for you, but I just thought I'd throw that little, thought process out to you so you can chew on that later on when you're at lunch. You're eating and you're going to think, that was interesting. Whenever you add two numbers that are the same, you always get an even outcome. Remember that for the SAT. That's one little thing I'm going to give you. So what should we call the two numbers? How about something that they're being referred to in the word problem? You see these? Smaller and larger. They're referring to them as smaller and larger. So why don't we just call them smaller, smaller, and larger? There's my two numbers. I have no idea what they are, but one's smaller than the other. It said the sum of the two numbers is 35. How would we write the sum of two numbers we don't know being equal to 35? Think for a minute. You can pause me if you want to try this. How much would I love you to just try and work through this without listening to me and then play me back? I think that would be awesome. Go, pause and try and do it. So those of you that didn't pause yet, come on. The sum of these two numbers, S plus L, equals, what did it say? The sum of the 35. Okay. It says that 3 times the larger number. All right, let's stop right there. I'm not even going to read any further. I'm going to break every rule that was ever told to you to read the problem first. I'm not going to do it. I'm going to stop right there. 3 times the larger number is. Where's the larger number? How would I write 3 times that? Exactly. That's 3 times the larger number. How do you write is equals? Okay, so 3 times the larger number is the same as 4 times the smaller number. Which one's the smaller? How do I write 4 times the smaller? Oh, okay. So here I have, and then it's saying find the larger number, and you're kind of looking around like, is anybody going to give me any more information? No. They gave you a hint that I erased. I want you, because, they're thinking you can't do this. I'm saying, oh, yeah, you can, because I've taught you a couple things in the past that can help you here. I want you to take a look at this, and I want you to ask yourself, given what we've done with the triangles and given what we've done with the rectangles, and we've looked for letters that can be expressed in terms of the same variable, you have S's and L's in both of these situations. Is there a way to use the powers of literal equations? And don't freak out just because I said literal equation. I see you eye rolling me. You know who you are. Stop rolling your eyes just because you don't like literals. Be open-minded. This is why I taught you literals. Do you see an expression that you could finagle into being either S equals or L equals really easily? All right, I do. I see a couple, but one way to get L or S in one of them would create fractions. That's there, right? Oh, that's there. The only way to get S or L alone in the case of this equation would be to divide by them, either a 3 or a 4. That's going to give me fractions, and I kind of try to avoid that. Let's look up at the top. Can you get S or L alone there? Absolutely. Why don't we try and get a L alone, just so we would know what the heck the larger number is in terms of, say, S. So if I try to get the L by itself, what would that be expressed as? Well, that would be S is equal to 35 minus L, because I'm just going to minus that L, right, to both sides. Now, if that's the case, then I just, squeaky, squeaky, I just reworded what S plus L is equal to. S is equal to 35 minus L. And I could have done it the other way around, but this is the way I went. So if I know that S, one way that you could write S is 35 minus L, I want you to look up here in this equation and tell me, just like we did with the triangle, we swapped one side in for the other. Is there any way to swap in what we know about S to the boxed expression? Oh yeah, there is. We see that S is equal to 35 minus L, right? And we see an S here. So what's the relationship between the S and the 4? It's multiplication. So we could write it like this. 3L, because I'm not doing anything to that side, right, equals 4. Now instead of writing S, I'm going to write the other way to express S in terms of L. What do you think is going to go in there? You're right, 35 minus L. Wow. So why the parentheses? Do you know? I needed the parentheses because I had to do 4 times the value of S, and the S was a 35 minus L. I'm going to have to distribute that. And if I didn't show parentheses, chances are you just would have times the 35 by 4, and you would have forgotten to do the same to the back end. And we don't want to do that. So you always use parentheses around quantities that have pluses or minuses in them, like this one did. You see that what we've got now is a very straightforward equation most of you have mastered at this point. 3L is equal to 4 times the quantity of 35 minus L. If you follow the yellow brick road on this one, you're going to come to the solution of what L is, and then you're going to come to the solution of what S is when you plug it in. I'm not going to hold your hand down that path, though. You're going to follow the yellow brick road. And you're going to try some of these problems if you're up to the challenge. Not everybody is up to this challenge, and I don't need everybody to be up to the challenge, but I want those of you that are looking at this going, hang on, I'm dying to know if this works out. I want to try and evaluate and find out. Excellent. And then you've got more problems here that you can chew on. Now, I want you to look at what they did here. They translated it and fixed it for you. They actually got the X by itself. They called it a different letter, right? They called it, whatever they called it, X, or the large number. That's it. They called L X, and so they wound up solving in terms of S. So they have the exact same thing that we have, except we have an L and we put the 35. Oh no, they did it exactly the same way as we did. So they did the translation for you, where I wanted you to learn how to do that translation on your own so that you could try to extend yourself to some of the harder or more saucy problems to get you ready for your performance task. This should keep you busy. If you look at this video and you say to yourself, I think I want to try more problems like this, I've got plenty more problems like this, but I've been guarding you from them. I've been shielding you from these because I didn't want them to confuse you. So try the ones that are on this page. They should kind of require you to do the same thing, and then use a check step like we did on the left side, just to make sure that your answer makes sense. That's all. And come back to me. I do have an answer key on this, and we can verify that you're not going about it in the wrong way or thinking you're right when you're wrong. So guys, plenty of practice. I'll leave you with the entire page so you don't have to go backwards or forwards. Here's the entire page for practice for you. And again, your answer key is your head at this point. It's your head and it's your group, because you're going to go back to the word problem, run it through with the number that you think is the answer and find out, does my answer actually satisfy the conditions or the constraints of the problem itself. And again, I made it just at 20 minutes. Very proud of myself, and I'm proud of you. Guys, follow the yellow brick road. 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 Follow, 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 follow the yellow brick road. We're off to see the math, the wonderful, wonderful math. See you on the flip side.